Hey YouTube, in this video we're going to be exploring just an example of finding conditional probabilities using both a formula and kind of a two-way table to do this. So let's go ahead and begin by reading the problem here. It says that a satellite TV provider surveys customers in 3 cities. And so it seems we have Glendale, Santa Monica, and Long Beach. It says that the survey asks whether they would recommend the TV provider to a friend. So these results given as the joint relative frequencies are shown in this two-way table. And so we say the response was either they would recommend it or not. The nice thing about this table is that it's not giving actually the joint frequencies but the joint relative frequencies, and that is to say that these are the likelihoods that they would have said yes or no given that they live in a certain city. And so speaking of given that is to say, when we make statements like given that they live in a certain city, that's when we're starting to talk about conditional probabilities, because the way they answered was probably dependent upon where they live. So when we look at these probabilities here, we say, starting with letter A, it says, what is the probability that a randomly selected customer who is located in Glendale will recommend the provider? Well, the first thing we want to do is write down our probability. And because we're saying that they're already located in Glendale and asking how likely it is that they will recommend, we're looking at a conditional probability. So essentially we're going to say, what is the likelihood that yes, they're going to recommend? Okay, so we'd say recommend, given that they are from Glendale. Okay, so when we rewrite this, I'm going to abbreviate this a little bit. Remember that the probability of an event occurring after an event A has already occurred, given that A already happened, we say is the probability of A and B. You notice that A and B switch around here from one side of the equation to the next, and this is all over the probability of A, or our first event that occurred here. So when we look at this here, we'd say, okay, well, probability recommended given that they live in Glendale. When we rewrite this, it would be the probability of Glendale and recommended, okay, essentially, and this is all over the probability that they live in Glendale. So looking at our relative frequencies here, our joint relative frequencies, we could say, well, then the probability that it's Glendale and recommended would just be the intersection of these two here. We'd say 0.29. Now, the interesting thing that happens here is that we say, well, what's the probability they live in Glendale? You notice that people that said yes live in Glendale, but also some people said no. So, you know, how many total people, or what percentage of the overall amount that we asked here live in Glendale? It would be the sum of these two joint relative frequencies. So we're going to have to find our marginal relative frequencies here. We get 0.34 here. Here it looks like we get 0.30. Here it looks like we get 0.36. And so when we extend this way, as a matter of fact, this should all add up to 1.00. But also, if we were to add across, how many total people say, let's start with the no's. It looks easier to add up. 5 plus 3 plus 4, that'd be 12. So we say 0.12. And I'll tell you, because I know that this frequency here has to add up with my 0.12 to be 1, I know that this is 0.88. So I saved myself a little bit of trouble here. So we say the probability that they live in Glendale at all is this marginal relative frequency right here. We'd say 0.34. Sorry about the green marker there. So we'd say, okay, we're going to take our 0.29 divided by 0.34, and we get about an 85.29% chance. So approximately 0.8529-ish, which is about an 85.29% chance. And just to interpret this, really all we were saying is, of the people who live in Glendale, what percentage of them would recommend it? And as you look at just Glendale, again, we're just looking at just this here, we're saying overall the majority preferred it and said yes, they would recommend it. So when we look at letter B here, let's go ahead and take a look at letter B. We say, what is the probability that a randomly selected customer who will not recommend the provider is located in Long Beach? The question really starts to become this, you know, which part is already given as the given? And so we're saying that I want to know how likely it is they won't recommend given they live in Long Beach. So Long Beach comes first. So we'd say, oh, sorry, not comes first. It happened first. But when we write this out here, we'd say, what is the probability that they'll not recommend? So we say not recommend, given that they live in Long Beach. So let's go ahead and re-scribble this one here. Switching our orders around, we say probability of Long Beach and not recommended, okay, over the probability of the first event here, which is the Long Beach. So we'd say, looking at our relative frequencies here, we could say that probability of Long Beach and not recommended in Long Beach was 4% of their the overall respondents there. And we'd say, okay, how about the probability that they live in Long Beach would just be this marginal relative frequency here, 0.36. And so this right here, as we put this into our calculator here, we'd say 0.04 divided by 0.36. I think it's an eighth. No. Let's try this again. 0.04 divided by 0.36 Interesting, interesting. So it's a ninth. Okay, so we get 0.111. So 0.1111 is equal to 11.11%. So essentially, it's not very good that you would say, no, don't use this if you're from Long Beach, because again, overall, the majority in Long Beach here, they prefer to recommend it. So